Well, hi again. This is Al Bastifer with continuing education and training, this time pertaining to the RCCD control valve. The RCCD control valve is a refrigerant capacity control device that is installed basically into the condensing section. There's other options available, but they will not be discussed on this training segment. The RCCD is pretty simple and is very adjustable and adaptable. If you'll notice, this is a quick selection chart for 1 to 10 tons. But what I want to point out is that this could be a 10-ton compressor that is part of a 40-ton package unit, or it could be up to 15-ton compressors. It doesn't matter. The RCCD basically can go on any size piece of equipment from 2 tons to 200 tons, and the application will depend. But I just wanted you to know that this is very versatile, and the only limitations we have on this is the suction line riser size. So for those of you that are technicians getting ready to install this, I encourage you to confirm the sizing. In other words, if you have a 3-ton package unit or a 3-ton split, with a 7/8 OD line, suction line riser, the 1 is what you'll be using. If for some reason they gave you a 2, you need to return it and get a 1. This is the final way that we can ensure that we don't overcapacity or over modulate the system. 3 basic components of this valve. This valve is patented, and the 3 components are the hot gas modulating, the desuperheater valve, and the atomizing chamber. We'll go into detail on all this, plus other information as we flow through these slides. RCCD control. The RCC control is coated with a corrosive resistant product by the name of Blygold. Blygold is well known throughout the world as being the best corrosive resistant product there is. That's what this means, that this can be mounted in any environment, unlike our competitor. And it can be inside, outside. It could be, there's a whole bunch of advantages that this has over the competitor. As we go through this, I'll mention a few, but there's much, much more. The RCCD control valve is a flow-through control valve. So there's no possibility of trapping oil in the controller, unlike a major competitor. A major competitor, what they do is they got a body, and inside of it's a pickup tube that comes down about 1/2 to 2/3 of the way, and it flows in there. Oil can get trapped in the bottom. So if all of a sudden you have a huge modulation chance, that oil can be pushed out and it can go all the way into the compressor. Also, there's a possibility of liquid slugging with that liquid accumulating in that part of the valve. With the RCCD, that's not possible, because as you see it here is the mounting position, one of the many mounting positions. So there's no possibility for oil to be trapped or refrigerant to be trapped in a valve. It is a flow-through valve. This picture is not wrong. There's nothing wrong with it. What this is showing is one of the many mounting positions the RCCD valve can be completed with. Because if it's a flow-through device, that means that you can, on a horizontal line, you can lay it on its back as long as you don't have an oil trap. You can come straight in. You can go on a riser from the side. You can flip this valve as you're looking at it 90 degrees over with the external equalizer, which is part of the valve there. You can flip that up, and then that valve can be mounted like that. So there's a lot of stuff. The only limitations, not upside down, and not with the external equalizer under the valve. In other words, you got a bunch. Where this has a big advantage is in really compact situations, such as geothermal heat pumps. Yes, this can be used on heat pumps. The wiring diagram will be later on in this presentation. Connection information. We'll start over here on the right. The liquid line connection suggested a small liquid line dryer. The reason being is that port that's inside that valve is very, very small. That dryer is not to be used. We're not worried about the desiccant value, but just the filtering value of that. And the reason being is that's what protects your compressor from overheating. If we're bypassing a lot of hot gas, it will allow liquid to come in there and quench that hot gas and keep it cool so that your superheat of your compressor is maintained. Only time you would need it is mandatory to have a ball valve on there is if you don't have a ball valve on your suction discharge, which is the blue line down below. And if you don't have a ball valve there, you'll need two ball valves, one on each one of this one and the hot gas connection. And the reason being is that you need these ball valves on there to be shut off during charging and diagnostics. In other words, if you try to diagnose a system with this thing modulating, it's going to be really confusing. And if you try to charge, you're going to overcharge because it's always going to be accommodating in trying to maintain superheat and subcooling. Suction line connection for all four valves that we have is a 2-size fitting on the RCCD. The external part, is 5/8 OD. And that's so that you can put a 5/8 valve and go right over the top. Be aware that this thing being coated with Blygold, you'll need to remove all that Blygold off of there. And Blygold is very hard to remove. It's scratch resistance. The internal part of it is 1/2 inch. So with the high 1/2 inch OD inside, that means you can take a 1/2 inch line and connect it in there. One thing that needs to be known is that you don't reduce that line. 1/2 inch is as small as you can go with that line. I would prefer 5/8, but 1/2 inch is as small as you can go with that line. A ball valve is mandatory on this line, again, for diagnostics. Again, it's a flow through. You're going to cut off the flow through the valve and maintain and I basically isolate the valve out of the system. Hot gas connection. Again, ball valves are only needed if you're unable to put one on the suction line, or I highly recommend a ball valve on each one if you have a large split or something where there's a large refrigerant charge, in case if you got to isolate the RCCD from the system for any maintenance, repairs, or replacement. The ball valve here for all three connections is highly suggested on splits, as I just said. The superheater information. I'm pointing to the adjustment point on the desuperheater, but then I say in there, do not adjust. This, do not take out, it's factory adjusted. We adjust it so that we make sure we maintain the integrity. If you adjust this wrong, you can cause a liquid slug to go to the compressor and have a detrimental effect on the compressor. You do not bother that at all. This is a sensing bulb, and it is installed right there. Of course, whenever you're doing any soldering on this valve, you take that bulb off and you protect the chamber and everything. Inside that chamber, you'll see is a specialized fill, and we want to make sure nothing gets overheated. If you want to insulate that bulb, it's okay, but don't insulate the whole chamber. There's a reason for this, and part of that reason is that the transfer of the excessive heat that's coming out of the hot gas helps out with that chamber. Hot gas modulating part. This bulb that you see there is not a sensing bulb. It can be mounted in a lot of areas. One that we mount it to whenever we're sending out the 2, 3, and 5 valves is right to that external equalizer. It can be maintained right to the external equalizer. That valve, that's actually a bulb. The company that manufactures that valve for us, which is Danfoss, has specially modified the inside of this because it was a TXV to become a hot gas valve. So only this valve can be purchased through us, and it has a special part number associated with it. The adjustment on this in here, go play with it. Do whatever you want. It basically adjusts from 30 degrees saturated suction to around 55 degrees saturated suction. We will talk about adjustment briefly, but there is a more in-depth training and the advanced training for adjusting this valve and maintaining what I call the humidity ratio, or understanding what you're trying to do. Give you a brief thing. If you're wanting to maintain 75 degrees and 50% RH, you will need to be below 55 degrees saturated suction on your evaporator. So that's where in the world we'll start at. Down at the bottom, both of these valves right there are where you hook up your lines to. Now, with the exception of the 410-5, the 410-5, the adjustment's on the bottom of the valve over there, and it's a service valve type adjustment, and the connection happens to be right where the adjustment is on this and here. But all the connections there, those valves are stainless steel, and the inside of those connections are cladded with copper. Use proper solder. Do not use soft solder or stay bright top solder. Use something that is a 15%, 45%, whatever you feel comfortable using. But as always, protect the valves from overheating, because if you allow them to overheat, you'll ruin the device. Suction line connection, the chamber, this chamber that is everything's connected to, and if you can see my pointer over here, this is about the dividing point. Whoops, excuse me. This is the dividing point right here between the high side and the low side. Over on this side is high, on this side is low. Same thing over here. Dividing point, this is low, this is high. That chamber has been tested to 2400 PSIG before bursting. So you should never see the pressures in that chamber that will even get close to a safety aspect. Also, that whole chamber is made of copper, and so is the connection down here. Make sure you remove the Blygold. The Blygold is causing more soldering issues than you can imagine. If this is going into a corrosive environment, get a hold of myself, and we'll see if we can get you up some touch up so you can touch up the Blygold. Again, Blygold is a very, very good product for corrosion. The RCCD is installed in the condenser section or in the condenser. There is rare occurrences where you can install it elsewhere, but again, we're not going in. This is basic training. Provide support. That's one thing I see. They'll set the valve up and they'll have it sitting right on top of a suction line, and it's just sitting there. Well, with vibration and weight of the valve, you're going to cause some lines to break. You need to provide a unistrut or something around or a strut clamp going around that valve to hold it in place. No matter what, this valve has some weight to it and will need to be supported. I don't care if you support it on a back wall or however you do it. Remember, it has multiple mounting positions, just can't be mounted upside down. With multiple compressors, this is something that you need to know. You connect it to the manifolds, okay? And multiple circuits have another issue, but being connected to the manifold, okay? Multiple compressors, single circuit connected to the manifolds. If you note 1 says location if a solenoid is needed. There is times whenever the valve is installed, let's just say a 40-ton system with 4 10-ton compressors, we're not worried about going below 10 tons of capacity. Our issues happens in between compressor stages. So you put a valve, a solenoid valve on there, and when the second compressor comes on, or the second stage, it opens it up and gives you modulation. We may be limited because of suction line OD size on when or where we can put it on. Additionally, there's times whenever you'll have more than one valve on, and the second valve will come on with the addition of more compressors. When you have multiple circuits within a system, that will present a whole different issue, and that will be gotten into more in depth on the advanced training. Works on heat pumps, works perfectly on heat pumps. Just pay attention where you connect the suction line side. If you look at it, it's connected between the reversing valve and an indoor coil. If that reversing valve now flips and goes into the heating mode, all 3 points are on the high side, which means no flow through it. The only thing is if you would connect this down below the reversing valve, down in this area here, what'll happen is when it goes in a heating mode, that will unload the compressor, unload the system, the colder the outdoor coil got. And that's something we wouldn't want to do. So again, it works great on heat pumps, just got to know where to connect it. This is a letter of recommendation we got, and this is an example of where we had a problem. And in this case here, to give you a little bit of a idea of what the problem was, is that we had a huge humidity issue on convenience stores on the Gulf Coast. Now, the equipment we was putting it on happened to be 2 circuits, 2 compressors, and then they had another issue with the split phase coils and some other things. This is where we did the diagnostics, got in there, worked with the contractor, solved the problem, and then they were able to roll it out to multiple locations. And by the way, it took that humidity issue and squashed it. No problems whatsoever. Conclusions: it solves most, if not all, common issues dealing with DX equipment, gives the unit the ability to dehumidify, increases energy efficiency by extending runtime, and not allowing energy used to be wasted. That's critical in that there is a delay between the time whenever you start removing humidity and the runtime of the unit, normally about 15 minutes. That's all going to be in more in the advanced training. Easy to install and set up and forget. Units are designed at 45 degrees saturated suction. That needs to be the beginning. Sizes from 2 to 200 tons. Applications only limited by the designer installer. Oil entrainment is the critical item. We can't entrain the oil in the evaporators or in the lines. Advanced training for all of the advantages, the RCC. There is so many advantages that the advanced training is going to be extremely long. This gives you an idea how to get it in, get it going, get it up, and get it working. Now, this ain't the end. I take that back. It is. Thank you and have a great day.